All right, so welcome everyone to the return of the mesh, the Gateways API epic quest for Unity. So, first of all, how are you today? Good? All right. So, do you like Star Wars? Yeah. So I'm going to try to bring that theme. How much are you using service meshes here? Few hands. Who doesn't know anything about service mesh? Ah, few, okay. So I'll try to answer a few questions. And who is using the Gateway API? Few hands. Who knows anything? Who doesn't know what is the Gateway API? Couple of hands. All right. So let's start. My name is Henrik. I am a cloud native advocate working at Dynatrace a bit more than 4 years now. And I'm also a CNCF ambassador. And I'm very excited to be interacting with this amazing community. The cloud native community, I think, is just amazing. But prior to that, I spent my career as a performance engineer, so testing, breaking, tuning, optimizing systems. And you'll see that this presentation is pretty much with my performance engineering hat. So that's why when I have time, oh, interesting. When I have time, I try to produce content on a YouTube channel called PerfBytes, which should be displayed somewhere. Okay. Ah, much better. All right, so I lost a couple of minutes, great. So I try to produce content on a YouTube channel called PerfBytes. If you're up into the performance engineering world, check it out. It's out there with Cherry Methodology. And otherwise, since 4 years, I have a YouTube channel called Is It Observable, covering topics about security, observability, of course, and Kubernetes. All right, so let's start. A long time ago, far, far away in the galaxy, we had a couple of service meshes in the CNCF landscape fighting each other. So Kuma, Istio, Ambient, and all those, they were all fighting it together. But a whole new hope arose in the galaxy, and it was the Gateway API. And you look at it and say, oh, it's so promising. Let's try to figure out if it's going to actually resolve our pain when we are in a journey of using service meshes. So for this, I had done some tests, and I can guarantee I was very, very nice with each of those solutions. And the intention of this solution is not to blame any other project, or in the opposite. I love each of those projects. It's more about giving you some feedback and then give you maybe some tips on which solution would be the best for you guys. So let me introduce the Clang. So we have first Kuma. Kuma from Kong, one of the service mesh from the CNCF landscape. We will see the advantage and disadvantage of it. Then we have Linkerd for Buoyant. I have, in fact, in that service benchmark, combined Linkerd with K-Gateway, because I don't know if you know, but Linkerd doesn't have the Ingress support, so I have added K-Gateway. Then we have Istio, the wise Istio. Everyone knows about it. So it's there, very powerful. And then recently, he has trained his Padawan, Ambient. So Ambient is very powerful, we'll see, but it missed some few things. So that's why we have a new couple that will work together, Ambient and K-Gateway, and we'll see what are the advantage of using both. So let's cover the new hope. The new hope is the Gateway API. So for those who never heard about a Gateway API, when we are currently building Ingress rules, we are relying on Ingress controllers. And in the Ingress definitions, we have a mix of platform things with certificates and everything, and then we have the routing pieces. So it's a bit mixed because you have one guy who is responsible of the certificates and one person more on the routing. So it was a bit of a mess. And thanks for the Gateway API, they have separate those leaderships. So we have the one hand, the gateway, which is going to be owned by the platform with all the security aspects. And then you have the routing, who could be owned by the teams itself. So with the Gateway API, we can define north-south communications. I will explain that in a few seconds if you're not familiar with this. And then there is a new initiative called the GAMA initiative. So we're going to focus on these GAMA initiatives in these solutions. And then recently, the Gateway API introduced the Gateway inference support, which is very exciting for every machine learning workload that you may have. So at the end, you have a CRD in your cluster, where you can define how you want to route the traffic within your cluster, and it provides a couple of features. The other thing which is interesting, similar to the Ingress controller, you have the actual APIs, but there's no implementations. That's why, similar to the Ingress controller, you will have a Gateway class saying who is responsible of managing the network. And each of those solutions will be basically a Gateway class that we will use on our gateways. So on the north-south, communication is basically the ingress rule. So we have the gateway. We define who is going to take the traffic coming from the outside world. So that is pretty like an ingress, so nothing special. For this, I think everyone has been using it, quite easy to use. And then we have the other pieces, which is more on the GAMA initiatives, where you can have now the east-west communications, where you can have an HTTP route, where you have the source of the traffic is a service, and the backend will be another services, which is exactly what we want to achieve with service meshes. But there are some limitations. The actual CRDs that we have in our hands, they are HTTP route, the GRPCRoute, TLS routes, TCP routes, and UDP routes. So the HTTP routes have a couple of features included, like the traffic split. So if you have different releases, it's perfect. The request mirroring, so for layer 7s, request timeout. And if you want to do backend timeout, they have a CRD called backend traffic policy, which is exactly what we need. And if you have a timeout, you maybe want to have a retry, so it can also manage a retry on HTTP. And then circuit breaker is not supported, so there's no way of doing it. And then if you look at the gRPC, you can see that we have less feature covered. So if we want to do more complex routing with gRPC, for now, the CRD doesn't allow us. And of course, for the others, it's not going to be layer 7 related, so it doesn't make sense to have the support. Now, there's no policy, as you can see. So meaning, how can I define a circuit breaker? Or how can I define a very specific service mesh policies with the gateway API? And for this, they have introduced this notion of extension reference, where you have a route, and you will make a reference to the actual policy. So for example, if I'm using Istio, I will make an extension ref to that Istio policies, or Linkerd, or whatever. But the thing which is complicated as of now, if you look at the GAMA initiatives, there's two ways of doing it. The first stop with the extension ref, or now it seems that the future is to use the target reference. You have a policy, and in that policy, you will target a specific route. But as of now, if you look at the different mesh available, the target ref is not implemented everywhere. So it's a great feature, a new hope for us, but it's not there. So at the end for us, it's a no. We still have to go back to the configuration of each service meshes. So the current state, if you look at the product that I mentioned, here is the current support. So most of them supports the API gateway, no surprise. It supports the GAMA mesh initiatives. They all support it in a certain instances. And then if you want to go further away with AI, with the AI gateway, and the inference is mainly Istio family that supports it. And the AI gateway, I put a star because K gateways has that support. The other, of course, doesn't have it. So let's now jump into the differences, because at the end we know we're going to use HTTP routes, but we'll still need to define the policies in each service meshes. So we look at every service mesh, compare their design experience, what are the components we required if you want to run those meshes in our cluster, the observability, because again, observability is a feature of the service mesh, how can we enable it, and what type of the data we're going to get, and then I did a small benchmark and I'm going to share it. And of course, I will share some recommendations. All right, let's start with the components. So for those who are familiar with service mesh, you say, that is obvious, but for those who never heard about service mesh, I will explain. In every service mesh, you have a control plane. So when you are defining your policies, you will interact with the control plane, and the control plane will define the policies and put it in our data plane. The data plane is designed with our app plus a proxy. You need a proxy to delegate the actual routing or the proxy or the policy that you've defined. Meaning that with this proxy, because every traffic will go through our proxy, we will have extra statistics about incoming, outgoing traffic, and so on. So naturally, all those components will generate metrics, traces, logs, and more. So this is a feature that we were expecting. But there's a family. There's basically two clans hanging out here in the market. We have the sidecar model and the cycle-less. Cycle-less, I think, is the feature, but we still have an heritage of the past. Sidecar model, for those who never heard, it means, of course, we're going to inject the sidecar in our containers. The advantage of that is going to be local host communication between our app communication to the proxy. And the proxy, if you send a traffic to another service, it will go to another proxy, and the proxy will communicate back to our app. So very efficient, very low latency, but the big disadvantage of a sidecar is that You're just adding more CPU, you allocate more CPU, allocate more memory, so at the end it's more expensive in terms of resource perspective. Then you have the cycleless, which is the vision that Istio had initially in the past. So they provide one proxy that sits on the node that will be in charge of the layer 4 communications, so TCP, UDP. But then if you want to do more complicated routing with layer 7s on the headers or on your URLs or whatever, you will need another proxy that will be responsible to do that type of work. So if you look back on the family that we had initially, Kuma is going to be sidecar, and it has Envoy, but it's the modified version of Envoy. Linkerd is using, again, a sidecar, but it's going to be a Linkerd proxy. Istio is, of course, Envoy, we know that. And then if you go to Ambient, they use zTunnel as a node proxy, plus if you want to do layer 7 communication, it's going to be Envoy. And then you can combine Ambient with Kgateway. So now we replace the Envoy with the Kgateway proxy instead. So let's have a remind the force that we expect. When we are dealing with service meshes, there are specific features that we need. So we need, first, ingress and egress communications, obviously. We need to be able to put certificates, so mutual TLS, between every endpoints, every services that we have, so the traffic is encrypted. We want to do traffic split. So we have two versions. I want to say 20% to version 1, or version 2, and 80% to version 1. Traffic split is a very useful feature. Circuit breaker, very important if you have different endpoints to figure out if the one endpoint is unhealthy based on the rate limit, for example, on the number of requests per second. Timeout, if an endpoint is slow, we don't want to jeopardize our architecture, so if we're going to put a default timeout, then we have the retry, so if the application is not responding, we're going to retry. How many times should I retry until it's actually answering? Then, of course, the observability are going to be an important features as well, because at the end, we expect to have more visions on the network perspective. So if you look back to the toolings, every tool here has pretty much the support that we expect. I've added inference for the LLM. You can see that it's only the Istio family that has it. But the idea, if you pay attention to Ambient, it doesn't have circuit breaker, and it doesn't have retry, and also a rate limiting. So that's why I combined Kgateway with Ambient, and you can see here the missing features will be now available due to the support of Kgateway. And by the way, if I go back, Linkerd doesn't have Ingress. Here I get the Ingress because I'm adding Kgateway. That's one important thing to remind. So design you must. Yes, every solution has its own CRD, its own sets of configuration things. So let's go over each solutions. And here we have the left side where I don't want to use Kgateway, the API gateway, but here I want. So I want to define a gateway. And then I don't have to create a mesh or anything. I just have to create HTTPRoute or GRPCRoute, and Kuma will manage it properly. But then, like I said, circuit breaker is missing with the HTTP gateway API. The rate limiting is missing. There's a couple of features missing. So this is where I'm going to use the specific CRDs from Kuma to be able to achieve it. And like I said, the other thing which is important is the configuration. And Kuma has tons of CRDs, but it's pretty straightforward. I want to do rate limit. I will go for mesh rate limit. I want to do timeout. I will go for mesh timeout. So very simple. If you want to add your apps in applications to the mesh, just one simple annotations into your workload or namespace, and that's it. And the configuration, like I said, is pretty straightforward. So I think that's one of the advantages of Kuma. Linkerd, same thing. If I don't just want to use the gateway API, I can use HTTPRoute. So I will do the routing, the traffic splits, every feature supported by the actual by the HTTPRoute. But then if I want to do circuit breaker or rate limiting, I will rely on service profile, CRDs, and then HTTP local rate limiting policies to be able to rate limit my traffic. So I will still need this using extension references. And then Linkerd, if you want to add your payload to the mesh, simple, using annotations, and that's it. It's going to be part of the mesh. Now, if you look at Istio, and you see that Ambient is going to be similar, you have a lot of CRDs in Istio, but we just forget about virtual services because we're going to mainly use HTTPRoute and GRPCs, and we will still need to use destination rules for circuit breaker policies, and envoy filter because it's on the envoy, we want to put some rate limiting conditions. So again, another set of CRDs required. And then similar to the other solutions, if you want to add your app into the mesh, you simply need to add annotations to inject the actual new proxies. But again, keep in mind it's going to be a sidecar, so you'll have to restart all your apps. So then the sidecar will be injected into the workload. Ambient, here we don't need to restart. So Ambient rely on the same CRDs as Istio. So if you've been familiar with the Istio, the transition will be quite straightforward. It has like a Z tunnel on each node. And then if you want to do the layer 7, all the policies of a circuit breaker or rate limiting or anything, this is where you're going to add a waypoint. So you can add it per namespace or per workload. It's very simple to add it. And then to enable, you will have similar things than before, adding a specific annotations, saying, this data plane is going to be ambient, and here my workload requires a waypoint, and I'm going to find which waypoint I want to use. Now, like I said, we have some missing support of CRDs with support of policies with ambient. That's why I'm going to add kgateway. And kgateway introduced this component called, this CRD called Traefik policy. And Traefik policy will do a lot of rate limiting, retry, a lot of the new things. So here, our game is, instead of deploying a waypoint, which is going to be envoy, we deploy a kgateway that will act like a waypoint. And to use it, you just say, OK, the waypoint I'm going to use here is kgateway and not the envoy waypoint that ambient comes into the game. So in terms of design, I think I really like Kuma because it's super simple. The docs are straightforward. It has the gateway support. All the family of Istio is wonderful. I put a star in terms of features of ambient because it doesn't have the full-fledged support that we expected. But then if you combine with kgateway, you can see that everything is smooth. Linkerd, I said that the docs is a bit more complicated, but that was my personal feeling at the end. Maybe you have a different feeling on that. So let's cover the observability. Now we want to enable observability. How do you actually achieve this? If you look at Kuma, again, I have a CRD for that. I want to do traces. I'm going to use mesh trace. I want to do metrics. I'm going to do mesh metric. I want to do access log. I'm going to use mesh access log. And they have a full support for open telemetry. So I'm just going to produce, so each proxy will emit OpenTelemetry traces, metrics, and logs. But then in the control plane, it doesn't have OpenTelemetry support, meaning that I would have to configure, to scrape the metrics because they essentially expose Prometheus metrics on the control plane. Linkerd. Linkerd has an extension, Linkerd Wiz, to see the traffic. And then if you want to enable the observability, you have to deploy an extension called Linkerd Jaeger. Of course, if you want to use Jaeger, it will deploy Jaeger, but you can say, I want to use Jaeger extensions, but I don't want anything, just use my collector, and please use OpenTelemetry. In that regard, it will emit traces using the OpenTelemetry protocol to your collectors. But the rest, the metrics on your proxies, the logs on your proxies, they are still in stdout, and the metrics are still in Prometheus. So you will have to, one part will be on the collector, and the other part will be through scraping or collecting with log agents. And on the control plane, similar to the others, they emit metrics from a Prometheus format. You will have to scrape those to get the health of the control plane. Istio and Ambient, I covered both of them because they do the same way. You have a mesh config where you deploy your mesh, your Istio or Ambient Mesh. You can say, hey, I want to enable the OpenTelemetry support. I want to generate the open access logs and everything, and it will do it. Otherwise, they have a telemetry object where I can customize. Oh, this particular namespace, I want to sample less and get more details. So telemetry objects can customize the way you're going to produce the metrics. Similar to the other solutions, so it supports OpenTelemetry for most of on the proxy side, but on the control plane, it's going to be still Prometheus metrics. And also one thing, on ambient. If you want to have traces, of course, it's going to be on layer 7, so you need a waypoint proxy to be able to get traces. So if you look at the observability side, I think everyone is pretty good, solid. The configuration is quite smooth. The OpenTelemetry support is here. The detail expose is here. I put Linkerd with less stars simply because the configuration, you need that Jaeger extension. It would be so smoother to just have it by default. And then OpenTelemetry, by default, it uses B3, the trace propagations. So you have to turn on the OpenTelemetry. I think it would make more sense to have it by default. And on the detail side, it's less detailed than on the data that they expose. All right, now let's cover the performance. So now that we have covered everything, I did a set of benchmarks, and I wanted to measure two things. I want to measure how much latency a mesh will add into an end-to-end transaction. So covering, in my case, it's 14 microservices, and then see how much latency those proxies are adding in an entire end-to-end transactions. And then I also want to measure another thing is how much this control plane will cost, or those proxy will cost in my cluster. So I did lots of benchmark. So here's the QR code to an environment. So if you have a very bad weekend, it's raining, you don't know what to do, have fun. Deploy it. And you'll see, you'll spend 2 days of testing, maybe more, in fact. And then you're probably gonna remove your Netflix subscription because you'll see that it's so fun to test those serious measures. So one thing which is important is that to do that, and you need to do first a test without the agent to get the baseline, and then you do a test with the mesh, and then so without any policy enabled, and then I do the same test with a policy enabled, and then I measure at every stage the thing. So I did quite a lot of tests, and I repeated tests on and on and on. And to be honest, I will share some results, and I'm not very proud of those results. Because I did a benchmark last year without the Gateway API, and I had different results. So I have rerun 3 times the test, and I get some results that is unexpected. So I will try to use, again, those tests, not on a Proxmox. Here, in my case, is on my home lab on a Proxmox cluster. And I thought maybe if I use EKS or GCP, maybe I will have stronger machines, and the results will be different. So I may rerun those tests. So the architecture is simple. I got the mesh. I'm using the OpenTelemetry demo application. It's the OpenTelemetry demo that provides 12 or 14 microservices. Then I use a bunch of collectors. So one is in daemon set to collect the logs, and then one on stateful set to collect the traces and the metrics and scrape the metrics from the control plane. And then here in my case, I'm sending it to Dynatrace, and Dynatrace will report the actual resource consumptions of all those containers. And by the way, if you scale on the QR code, there's another branch for workshop where you can spin up a code space on GitHub, and you select which mesh you want to test out and play around with the booking info applications that the Istio community has worked on in the last few years. So let's check the results. So now I just focus on a constant load. Here you can see that we have the response time on the top, and on the bottom I have the control plane, and then on the layer down is the data plane. You can see here the fastest one in terms of latency introduced is Ambient Mesh with 3 milliseconds. Then we have Gateway with 5, and Linkerd with 6, Istio with 7, and Kuma with 8 milliseconds. And if we look at the control plane, and that was my surprise, it was basically, if I don't see here, it was basically Ambient that was the most expensive with Gateway. And same thing on the memory. And then if I look at the data plane, no surprise, is the sidecar, of course, that are more expensive. The one which is in green, I think it's Kuma, and then it's going to be Istio, and then Linkerd, and same thing from the CPU. Then now if I deploy those policies using extension reference on my HTTP and GRPC routes, so I'm using the HTTP routes plus GRPC routes, here are the numbers. So now you can see that Ambient went to 3 to 6. Ambient and Gateway was about the same response times. And then we got Istio and Linkerd about the same response times, and Kuma again, the last in terms of latency. And then on the control plane, I have pretty much the same conclusion. Ambient was more expensive than the others. And on the data plane, here in my case, it was the black one, I think it's Istio, and then Kuma, and then on the bottom is of course the one that doesn't have any sidecar proxies. So at the end, as a result, if you look at the latency perspective, Kuma was obviously the slowest, and on the proxy usage, it was also more expensive on the memory as well. And then on the control plane that we saw on each test that I had, it was the Ambient family that was more expensive with Istio. But from those numbers, from when I did the test without the HTTP routes and the extension refs, I had completely different numbers. That's why those numbers, I'm not very confident about it. So I may want to resume, rerun those tests again to make sure it reflect the reality. So as a conclusion, from my perspective, 10 minutes. Because I have 3 minutes. Okay, I'm interested. That was unexpected. So I went very fast. So maybe if you want to slow down and go, oh no, okay. All right, so if I want to, as a conclusion, what I'm saying is that I think Ambient, just by the fact that it's very simple, you get a full-fledged support, very low resource in terms of the proxy that you utilize, the fact that you don't have to restart your apps to get part of the mesh, I think is fantastic. But like I said, it doesn't have all the features that I needed. I needed to do circuit breaker. I needed to do rate timer, rate limiting. I need to do specific policies for my cases, and that's why I combined it with K-Gateway. And I think the couple Ambient plus K-Gateway is fantastic because you get all the value of Ambient plus the feature missing and the details that you need when it comes to networking routing on between your services. So again, that's my conclusion. And if you've been using Istio, I would recommend to keep using Istio, but consider the fact that it's the same configuration. Let's try Ambient or Ambient Gateway. So I did a couple of episodes about Istio, Kuma, Linkerd, and others on my YouTube channel. So here's the QR code on the YouTube channel, so scan it, you can consume it. If you like the content, like it. If you hate the content, please hate it, but send me feedback, because without bad feedback, there's no way of improving your content. So please hate it, but let me know. So please love it as well. But all right, so I think I have 2 minutes left on the timer here. I have a QR code here on the feedback, so if you can go and send me some feedback on schedule, please do it. And if you want to chat or discuss about meshes, policies, observability, because I'm an observability geek, scan the QR code on under the chat message. And I would love to interact with you guys, because I think the community is so great, so having discussions is always awesome. Do you have any questions? Well, go on. So the question is the feature missing in provided by K-Gateway will be added in the Envoy default proxy supported by Ambient? The problem is no, because as of now, a proxy of Envoy, if you want to configure rate limiting, you have to do Envoy filters. And then this is a mess, because at the end, Envoy filter expect that you have specific thing. I'm basically in the proxy. And here you're outside of the container, so it's not possible. So as of now, the only way of doing those type of policies, you have to use K-Gateway. There's no other options for that. Any other questions? Gosh, I killed everyone here. I'm sorry. One question? Yeah.
Hi, I was just curious what your favorite go-to is.
My favorite go-to?
For mesh, yeah.
For a mesh perspective? Designing Kuma was very, I thought if you are new into the mesh world, I think Kuma make it so simple. So if you're afraid of going deep into the networking routing and configuration, Kuma makes it simple, but it comes with a price. So that's why if you are up into making the extra move and move to Istio, so I did that step, and then I think Istio has a full flash, and it's always supporting the latest and greatest from the K-Gateway. So that's I think makes sense. So every time there's a new release, K-Gateway, they support it. And then because with the inference, everything, so if I'm part of the Istio family, I know that I will always get the latest and greatest. So that's why I have this slight preference, to be honest. And I don't have something to say. I don't remember. Awesome. Anyway, all right. Do you have any other questions? Okay. All right. We have 5 minutes left. You can stay in the room.